Welcome students. Today we are going to have a discussion about HPLC. This is a very important chromatography analysis which has been more useful for pharmacists, especially wherever you go for work, maybe industry, teaching, wherever you go, you have to know the application of HPLC. I have not taken only the application of HPLC in pharmacognosy or in herbal isolation according to the chapter. If you just write application without knowing what is the principle behind and what is the technology behind, it's very difficult for you to write with understanding. So that's why I have not taken the complete details. It's a big volume. It needs more explanation, calculations, everything, how to identify. But in a summary, and also a student can understand in the basic requirements of an HPLC and how to operate and what is the basic principle behind, what are the different types in examination point of view, as well as you can apply this knowledge for various purposes. So I feel not only the 5th semester student, even the other pharmacy students of post graduation, even for the research students, even for the diploma students, all can listen to this class, and so that you will get an idea about what is this HPLC, what is its importance, and how because it became more freely available in all the field, and also especially pharmacy field. It's an important instrument. So kindly listen the complete class. It's not a very wide, very much maximum I have reduced within valuable points, not very much wider I have not gone. So kindly listen to this. Chromatography, this one is an important instrument, HPLC, high performance liquid chromatography. In some books they used to write even high pressure liquid chromatography, because we have used pressure here for the mobile solvent to move in the column. Column is also not as you think, it is not a very big, it's a very sophisticated and a minute and a small columns nowadays. Ultra performance liquid chromatography with a very interesting small short ultra columns are also available. So we should know what is this column, what is this high performance liquid chromatography. After knowing about what is the basic chromatography in the last 2 classes regarding TLC and paper chromatography, this is a very interesting chapter. The schematic diagram of an HPLC am just shown. It is for the solvent system, pump and column, injecting area and a database which is connected with the computer, and there is a detector, and the waste material can be collected for reuse, or sometimes it can be used for various other analysis also. So we will see in detail about this schematic diagram. This is the original instrument. The madam is working on it with a computer attached. We can see there is various compartments where the degassing, pump, mixing of solvent system, and the solvent system usually it will be kept in a different, in the top, which is not to be seen in this picture. We can keep in that side, you can keep if it is an isocratic or gradient. You know both the word. Isocratic means single solvent system, gradient means just increasing the solvent polarity or decreasing the solvent polarity by means of ratio of mixing of different solvents. System for mobile phase can also be used here. So you can see the graph which is shown in the computer, which she was observing about the separation of the compound. and a quantitative and qualitative also can be identified. You can see the types of HPLC technique based on. We have the category of, there are many types. In mode also, first you should know mode, normal phase chromatography and reverse phase chromatography. By mode itself it can be divided into two. By principle, you know very well, we have seen this adsorption and partition. This is a liquid chromatography, so it should work in partition, but adsorption also supports if it is solid can be packed in the column. Liquid chromatography, liquid is always used as a solvent system to pass through, no gas, so it is liquid chromatography, high performance liquid chromatography. Ion exchange by principle can be followed if you are using an ion exchange resin in the column of the HPLC. Ion pair, selective ion pair can also be used as a column, and you can principle can be utilized. Molecular exclusion, size exclusion, molecular exclusion, gel permeation chromatographies can be followed. Separated compound according to the molecular weight size in HPLC, but that is also one type, molecular exclusion. Affinity chromatography, specific affinity like various microbiology, biotechnology, tissue culture, various technology nowadays which we are doing, their specific component, if they want to separate, affinity chromatography can also be prepared a column, and which is useful. Chiral or chiral phase chromatography like optical rotation compounds, chiral compound which they are having carbon atom with different attachment of that you know very well in the basic chemistry you might have studied. That type of column is also available for separating chiral compounds, a dextro rotatory or levo rotatory R and S configuration which you might have studied very clearly, which can be used. Chiral compounds, chiral phase chromatography is also available. The third one, it is written 2, it is elution technique. By elution technique you can, this type of chromatography can also be differentiated by isocratic separation and gradient separation. That means one solvent system which you are using continuously the whole experiment, then you can say isocratic separation. Gradient means slowly you are changing the polarities, decreasing or increasing according to the requirement of your experiment. Then gradient separation also possible by eluting technique. And number 4 actually, principle is number 2, and number 4 is scale of operation. By scale, how much? By the scale of operation also you can separate. Analytical method means very minute micro analysis. Preparative little large quantities can also be separated and reprocessed can also be done. That is preparative techniques also can be followed. So by that also you can classify this HPLC. The fifth one, type of analysis. By type of analysis, whether it is qualitative, just to identify presence or not. Quantitative, amount, how much is present in the mixture of the compound, A and B or something like that, which we explained in the class. Separation of compound, mixture of compound is chromatography. So you can have 5 type of category HPLC technique. Based on their techniques it can be classified. Mode 1, 2 is principle. In the slide I made a mistake, that is you can see it is 3 is elution technique, 4 is scale of operation, 5 is type of analysis. Once again I just want to make you to revise, to remember. By mode you can have 2, normal phase and reverse phase chromatography. By principle in HPLC you can have adsorption and partition HPLC, ion exchange HPLC, ion pair HPLC chromatography, and molecular exclusion HPLC chromatography, and affinity chromatography, and chiral or chiral phase chromatography is also can be followed in HPLC. And number 3, elution technique can also be 2 types. By means of using isocratic separation, isocratic solution, single form of solution, or a gradient separation, then also it can be divided into 2. Scale of preparation, number 4, scale of operation, not preparation, operation, analytical, whether it is minute micro quantity or preparative large quantity in milligrams, then you can say scale of preparation, operation also HPLC can be classified by whether it is analytical HPLC or proprietary HPLC. Type of analysis also can be given. Two types of classification like qualitative and quantitative. Whether it is in just an identification or amount, determination of amount. So, it's clear for you there are 5 types of technical wise the HPLC can be classified. So, on basis of mode, chromatography, which we have discussed in the class about polarity and non-polar solvent, polar solvent, and how it is getting separated, polarity of a compound and a stationary phase and a mobile phase, what is its relationship in the separation of the compound, which we discussed, and I was telling about simple example of how the elution takes place or a separation takes place for a 4 compound A, B, C, D, which want to be separated in the column chromatography I explained in the class. So just remember about that, and you can just listen to this, you will get understanding what is the relation of polarity and non-polar and polar, or polarity characteristic of a solute, that means sample, mobile phase and the stationary phase plays a major role in the separation. There are 2 modes, normal phase mode and a reverse phase mode. These modes are based on the polarity of stationary and the mobile phase, and also the sample also, solute. Before explaining the mode, it is important to know the interaction which occurs between solute, the sample actually, stationary and mobile phases. Polar interaction or affinity is more. That means a polar and polar compound, their affinity, their solubility, their attraction is more. They will be linked strongly. When you see polar and non-polar, they are immiscible, the interaction is less and their affinity is less. This is very common, any student can understand. This holds good whether the interaction between solute, stationary phase, or solute and a mobile phase, the interaction can be easily studied by us. So first the normal phase mode. In normal phase, the stationary phase, example Silicagel, a polar in nature. In nature, they are polar. The mobile phase is non-polar. Obviously, we have to use. In this technique, non-polar component travels faster. That's what we are told in the class. Because they are not having any affinity to the stationary phase because they are non-polar. Polar is the stationary phase. This is because the less affinity between the solute and the stationary phase. Anyone can write this word. The polar component are therefore retained for longer time because they have more affinity towards the stationary phase in the column, because the more affinity towards the stationary phase, and takes more time to be eluted from the column. But the problem is, this is not an advantage for pharmaceutical applications because since most of our drugs, molecules, oral drugs especially, are polar in nature, not only oral, almost maximum we try to have a polar, to have solubility and distribution, disintegration, dissolution are the main process in our inside the body. So we used to use polar components more for drugs, and takes longer time, that it will take longer time for eluting and detecting. So we prefer always reverse phase, not normal phase mode. Hence, this technique is not widely used in pharmacy. So that is the reason the student should remember. So now you should know that what is the stationary phase, what is the mobile phase, what is the importance of polarity, what is the importance of what do you mean by polar, what is non-polar. Make it clear. The student can explain very easily. It's not necessary for you to go for any books reading or anything. Listen, write, go ahead. It's just write about examination point of view, and to write almost all the chromatographies can be easily followed by the student. Reverse phase mode, you just see. In reverse phase technique, a non-polar stationary phase is used opposite to the normal phase. The mobile phase is polar in nature, obviously. Hence, polar component get eluted first because they don't have any affinity towards the stationary phase. And the non-polar components are retained for a longer time because your stationary phase is non-polar. They are having more affinity towards the stationary phase. Since more the drug of the pharmaceuticals are polar in nature, they are not retained for a longer time and eluted faster. So which is an advantage for us to use in pharmaceutical industry, a reverse phase mode in HPLC. Different columns are available used. ODS means octodiol or octadiol silane, or you can see it is written C18, C6, C14, etc. The column, the number, column specification, there are many. Silane, methane, these all are types of columns are available. Based on the principle of separation now, with this also we have seen there are 6 types, there are many other types also nowadays available, understand. But just a common idea I want to give. Adsorption and partition chromatography together we have already seen what is adsorption, what is partition. Ion exchange chromatography also I have explained about in the class. Ion pair actually. Ion pairing is also possible, a chromatographic according to the selection of the column. Size exclusion, molecular CU or molecular exclusion, gel permeation chromatography, according to the molecular size you can just separate. The principle also HPLC can be followed to change the column and the mobile phase. Affinity chromatography in biotechnology, biochemistry, microbiology, we will be having specific compounds to be needed to separate even lively organisms. You can use some certain column which is towards affinity chromatography. Affinity means whichever having affinity towards the stationary phase will be retained, other can be released by means of another compound. Chiral phase or a chiral phase compound which is having dextrorotatory, levorotatory, optical isomers, optical active compounds can be used a chiral phase chromatography by means of using this particular column. So these 6 techniques can be followed, 6 type of techniques can be followed, 6 types of HPLC are available by means of principle of separation. So you just see adsorption and partition, again you know this very well. The principle of separation adsorption, we know that surface phenomenon, separation of component takes place because of difference in affinity of the compounds towards the stationary phase. This principle is seen in normal phase as well as in reverse phase mode where adsorption takes place. Partition HPLC, packing material based on the silica are also used as a partition chromatography. Earlier application, that means previously the initial stage of chromatography in 1960s and all, application of partition chromatography in HPLC involves coating the Silicagel in the column. In this case, acting as a support, the Silicagel as a solid which is support for the liquid to hold the liquid with a polar liquid as a stationary phase with the Silicagel solid as hold. Example, ethane 1,2-diol. It will get supported in the silica and stays as a stationary phase. Using as a mobile phase, a less polar solvent or a mixture of solvent, stationary phase, by dissolution in the mobile phase. Such packing by dissolution in the mobile phase in previous 60s, I want to say, have been replaced nowadays by silica to which polar phase are chemically bonded. Chemically, they are bonded. So you can have a stationary phase in a solid as a liquid will be chemically bonded. As we are talking about cellulose, which contain water as a surrounding molecule, which will act as a stationary phase. That's why we say that this paper chromatography will work in partition chromatography. So cellulose has the capacity to hold a liquid and looks like a solid and acts as a stationary phase. Remember this. Example of functional group in these chemical bonded partition HPLC, packing material are some of the example licroscope diol, mu bond pack CN, polygosel NH2. So in order to increase the polarity of the diol, cyano, amino can be added as shown in the samples. This type of chromatography, in which the mobile phase is less polar than the stationary phase, is called normal phase partition chromatography actually. But we are more interested in reversed phase. In reversed phase partition HPLC, the relative polarity of the stationary phase and the mobile phase are opposite to those of the normal phase HPLC. That is, the stationary phase is less polar than the mobile phase. And consequently, the solute are eluted in order of decreasing polarities. So you can see this silane, how it is bonded with OH, and with a radical, a substance can be added. You can see that chlorine as well as silane with a methyl group and an R radical, which can give rise to SiO, a ketone attachment. So the R can be C6H13, that is hexyl, or octyl C8H7, or even octadecyl, that means C18H37. Untreated silanol group, SiO, may be capped by treating with trimethyl chlorosilane to eliminate adsorption effect. So the stationary phase in silica chemically bonded through a siloxane SiO-SiC link to a lower polar functional group. These phases are prepared by treating surface silanol groups of silica with an organochlorosilane reagent. So this student should know that we can prepare by silica by bonding by using organochlorosilane. Is a technique. Nowadays advanced techniques are available. Advanced columns or ready-made columns are available, which already prepared. Stationary liquid, which you are interested to separate, that type of columns are available. So these are some of the picture of the columns. You see, small. Previously it was told 1 meter. Now it is very short columns are also, ultra columns are also available. Very, very minute particle size or very minute. So surface area will be increased. Separation is very fast. So the mobile phase is in reverse phase HPLC generally comprise water and as less polar organic solvent modifier, example methanol or acetonitrile. The separation of these systems are considered to be due to different degrees of hydrophobicity of the solute. The less polar solute partitioning to a greater extent into the non-polar stationary phase, and consequently being retained on the column longer than more polar solutes. In other words, they have written ion exchange chromatography. See the picture. Ions, anion, cation, anode, cathode, you know that. So, charged items. You are using a column with the resins, minute, very fine resins, which have ability to exchange They are charged atoms. The principle of separation is ion exchange, which is reversible exchange of functional groups. In ion exchange chromatography, an ion exchange resin is used to separate a mixture of similar charged ions. For an anion exchange separation techniques and factors affecting ion exchange separation on ion exchange chromatography is applicable to ion exchange chromatography of HPLC. Ion pair chromatography. See here, the siloxane structure which we have talked about, the bonding stationary phase, where the lipophilic alkyl chain which forms the bond with sulfonic acid, you can see that structure, free head group, which can be linked with a pair of positive charged nitrogen, which is shown that tertiary nitrogen, which can become a salt, quaternary ammonium compound of ion pair chromatography, analytical ion. So, the ion pair chromatography, a reverse phase column is converted temporarily into ion exchange column by using ion pair agents like pentane or hexane or heptane or octane, sulfonic acid, sodium salt, tetramethyl or tetraethyl ammonium hydroxide. Number 4, size exclusion or molecular exclusion, or it acts as a molecular sieve to separate according to the molecular size of the compound. Gel permeation chromatography, many words, different words they used to use. You see the picture? We know that gels will have pores. The small pores will be there. The smaller molecule components will be embedded, their affinity is more and they will stay for a longer period in the gel. Larger molecules, they will move through without entering into the pores. It can be separated. Just simple example which I told. In this technique of chromatography, a mixture of components with different molecule size is separated by using gels. The gels used act as a molecular sieve, molecular separator, molecular sieve, and hence a mixture of substances with different molecules or molecular sizes are separated. Soft gels like example dextran, agarose or polyacrylamide are used for this purpose. Semi-rigid gels like polystyrene, alkyl dextran in non-aqueous medium are also used. The mechanism of separation is by steric and diffusion effects. Affinity chromatography, which as I said earlier, this has more application in biochemistry, microbiology, biotechnology. Affinity chromatography used the affinity of the sample, the requirement of the sample, the loving of the sample, of the attachment of the sample, requirement of the sample, with a specific stationary phase will be selected. This technique is most widely used or mostly used in the field of biotechnology, microbiology, biochemistry, and various other techniques which we have followed even in tissue culture. Now this chiral phase chromatography or chiral phase chromatography, we can see this picture. Ketoprofen of dextro or R configuration, analgesic anti-inflammatory drug, and ketoprofen in levorotatory R configuration, slow periodontal bone loss can be happen. Both are having different therapeutic activity applications or pharmacological applications. See their configuration, structure is similar. Molecular chemicals formula is similar. Only their optical isomerism they are. So this can be easily have column in HPLC. Separation of optical isomers can be done by using chiral stationary phases. Different principle operate for different types of stationary phase and different samples, and the stationary phase used for this type of chromatography are mostly chemical bonded silica gel. Next, the type of HPLC based on elution technique. Elution, you know that, isocratic. In this technique, the same mobile phase combination is used throughout the process of the separation in HPLC. The same polarity or elution strength is maintained throughout the process. Then it is called isocratic. Gradient, 2 solvent, 3 solvent, 4 solvents. In this technique, a mixture phase or not a mobile phase combination mixtures of lower polarity or elution strength is used, followed by gradually increasing the polarity or elution strength by increasing the percentage of the other solvent. So that is called gradient type of elution. So based on the scale of operation, analytical HPLC, where only analysis of the sample is done, recovery of the sample cannot be done because very small quantity, reuse is normally not done in analytical quantity, since the sample is very low in microgram quantities. Preparative HPLC, where the individual fractions pure compound can be collected using the function of collector. The collected sample are reused. Separation of few grams of mixtures of HPLC. So the quantity, there is microgram, this is grams. And that is analytical HPLC, this is proprietary HPLC. Based on types of analysis also, qualitative analysis and quantitative analysis. Analysis, the experiment, this is having more detail, but I am just concluding, just a definition only, which is used to identify the compound, detect the presence of impurities, to find out the number of compound in the mixture which is given. This is done by retention time value. We can see that retention time value by means of the peak, by using UV detector 210 nanometer, and you will get the increasing in nanometer, you will get the peak. So by that, qualitative identification of the compound can be made. Quantitative analysis, amount, which is done by determining the quantity of the individual of several components in the mixture. Many are there means. This is done by comparing the peak of a standard and a sample. You can compare the peak of the sample and the standard. You can see the A and B, the width and the height will give you the concentration. So the unknown sample can be easily identified by means of comparing with the standard. And the quantitative estimates, amount also can be calculated. Different parameters are there, which I have not added. I have not got to that much extent. I am not going there. Instrument requirements. Now we are going to know about what all the instrument which is available in our college. We have in our institution. IR, UV, HPLC is an important instrument. So the student should know. You should go and see means what are the instrument parameters, what is the instrument have, different parts. It has pump, solvent delivery system because it is a high pressure, high performance liquid chromatography, high pressure. So pressure is given by the pump solvent delivery system. Mixture unit, gradient control, solvent degassing. There should not be any air entrapped. Degassing should be done by means of using helium. Helium is very costly, but degassing can be done by ultrasound techniques. Ultra waves can be used. So mixing unit, for even if you see a gradient control. Isocratic single, there also we need mixing unit, gradient control and solvent degassing. Injection, sample injecting manually or by auto injector, usually auto injector. And guard column, purification column. There is no separation that takes place in guard column. It acts as a filter. Any debris, any unwanted materials, any impurities will be removed by guard column. Number 5, analytical column. Number 6, detectors. And number 7, recorders and integrators. Now it is modified by means of computers, the recorders and integrators. So this is a 7 part. If you see the schematic diagram, whichever I told the parts can be seen here more visibly. This is the, just I have shown a conical flask, but not conical flask. There will be lot of different apparatus will be there for giving the solvent system. 1, 2, 3, 4 bottles will be there. But simply it should for you, this is the solvent system, first one. Next one is pump. Next one is injector, auto sampling injector. The sample will be supplied. And next one is guard column, which is act as a filter, remove the impurities from the sample and as well as the mobile solvent. And the next one is original HPLC column, which decides what type of HPLC you are doing and what type of separation is taking place. Next is the important part, that is detector. The detector can be UV detector, maybe fluorescent detector, maybe amperometric detector, maybe conducting detector. Many detectors are there. And waste can be collected and reused collector actually. And this can be connected with the data of a computer. That is the integrator. Data can be connected nowadays with computer. And you see number 1, again repeatedly I want to make the student to remember the solvent, gradient or isocurrent which is mixed and which is there, then a solvent, then pump, and even there is degassing, pump, all this comes in the second part. And the third one is injector, auto sampler, and fourth one is guard column, fifth one is HPLC column, and the sixth one is detector, and the seventh one is the waste collector, and the eighth one is data recorder, integrator, which can be done by a computer. See, these 7 parts is the schematic diagram of a HPLC. I hope the student can easily observe this. The pump and solvent delivery system, the solvent or mobile phase used must be placed through the column at high pressure at about 1000 to 3000 psi. This is because as the particle size of the stationary phase is few micron, 5 to 10 micron, the resistance of the flow of the solvent is high because of the minute. Hence, such high pressure is required. High pressure is recommended. There are different types of pumps available. There are mechanical pumps and pneumatic pumps. The mechanical pumps operates with constant flow rate and are used a sapphire piston. This type of pump is used for analytical scale. In analytical scale, pneumatic pumps operates with constant pressure and use high compressed gas, the solvent used must be high purity. When you are using in HPLC, preferably HPLC grade and filtered through 0.45 micron filter. Usually, before using any solvent in a HPLC instrument, they will be filtered by means of using a separate filtrate. By a membrane filter, we can filter it and then we can use as a mobile solvent. Check valve will be there. These are present to control the flow rate of the solvent and back pressure. Pulse dampers. These are dampen the pulse observative. That means the flow, uniform flow, pulse observed, and a wavy baseline will also cause in your integrating area in the computer if the pump is having a pulsative pressure. So these dampeners can be used for reducing this type of wavy baselines in the result. Second one, mixing unit, gradient control and solvent degassing area. Mixing unit is used to mix the solvent in different proportions. As I told, increasing the polarity, decreasing the polarity, slowly gradient and pass through the column. There are two types of mixing units. They are low pressure mixing chamber, which uses helium for degassing solvents. Other gases will be removed by helium. Mixing the solvent is done by either with a static mixture, which is packed with the beads, or a dynamic mixture, which is used as a magnetic stirrer and operates with high pressure. These all a stirrer which you might have studied, it can be used for mixing. Gradient controller. In isocratic separation, mobile solvent is prepared and using pure solvent and mixing of solvent. That is, the solvent will be the same eluting power or polarity is used for isocratic. But in the gradient elution technique, the polarity of the solvent will be gradually increased, and hence the solvent composition has to be changed periodically. Hence, a gradient controller is used when two or more solvent pumps are used for such separations. So students should understand about the importance of the gradient controller and how it works for this gradient elution, increasing the polarity. Solvent degassing is very important, otherwise the column will crack if there is an air entrapment. Several gases are soluble in organic solvents. When solvents are pumped under high pressure, gas bubbles are formed which will interrupt the separation process, which will crack the column, which will spoil your separation. Steady baseline and the shape of the peak, if you want, you need to do degassing. Hence, degassing of solvent is important. This can be done using any one of the following technique. One is by means of vacuum filtration, which can remove the air bubbles but not always reliable. Helium purging, very costly actually. Passing helium through the solvent, very effective, but helium is expensive. Ultrasonification, the new technique nowadays we are using. By using ultrasonification, ultrasonicator, which converts ultra high frequency to mechanical vibration. This causes the removal of air bubbles. Injector now. Manual injector and auto injector. Several devices are available either for manual or auto injector for the samples into the HPLC. Different devices are there. Septum injector, directly injecting by needle. For injecting the sample through a rubber septum. This is not common since the septum have to withstand the high pressure, may come out also. Stop flow, stopping the flow online time and then inject, which will flow the mobile phase is stopped for a while and the sample is injected through a valve device. That is one type of thing. But this one is very good, interesting. This was normally available in HPLC. Rheodyne injector, loop valve type. There will be a loop already injected, and in the computer you can feed 20 micro ml or 10 micro ml or 5 micro ml, whichever you want to feed. According to that, it will supply directly to the column. Sampling will be injected. Loop valve type. So in that I want to say, because you should know that loop valve, you have three that the load type and inject type. Load type, when you are injecting, it will be loaded, it will open, and loop type, you can see there is a loop where you are injecting and it will load into the amount will be decided and then it will be injected into the column. See, when it goes to the pump, from the pump it comes to the pump is coming, loop you are injecting, it enters into the column. If it is excess, it will come out. Excess will be vented out. That is what that system which I have shown. The picture is just for understanding. There is a vent is there, there is an injection port is there where they are injecting and loaded and enter in the loop and enters into the column. And when you are injecting area, you can see the connected. The loop will be connected to the column, and then when you change the knob, it will be released. There will not be any connection with the loop with the column. So the amount will be exact which can be injected. That is the main thing. Automatically, Rheodyne injector loop valve system. It is the most popular injector. This has a fixed volume loop with 20 micro ml, 50 micro ml or more. Even less also nowadays available in minute quantity separation, in ultra quantity separations. Injector has two modes. As in the picture, load position, the column is not connected with the loop. But inject mode, when you turn it, the loop will be connected with the column. You can see the picture very clearly. When the sample is injected with the injector, in the load position, the sample injected from the syringe through the needle port to the loop, not to directly to the column. The valve level then turns around 60 degrees when you turn it. The injector position, the sample swept, it will go swept into the following mobile phase. If the excess of sample flush to the loop, if you are did loop position, the volume injected will be returned. Is volume of the loop typically usually 10 to 20 micron ml of the analytical separation, and sometimes it is 0.1 to 0.1 ml of semi-preparative separation also. Quantity can be also increased. God column, as I told you, it acts as a filter. There is no separation. God column is very small quantity, that is quantity of adsorbent, and improves the life of the analytical column. It also acts as a pre-filter to remove the particulate matter or debris, unwanted matters, impurities. If any other material, dot column does not contribute any separation in your experiment. So nowadays even they are using many filters also in between. Analytical column, this is very important column. Analytical column is the most important part of the high performance liquid chromatography, HPLC technique, which decides the efficiency of the separation. There are several stationary phase available depending upon the techniques or quantity, more of the separation used. Column materials, we want to talk about column materials, simply some examples. The columns are made up of stainless steel, glass, polyethylene, that means peak also, or peak polyethylene ether ketone. Most widely used stainless steel, which can withstand the high pressure. Latest technique they are using this polyethyl ethyl ether ketone. Column length varies from 5 centimeter to 30 centimeter. Column diameter ranges from 2 millimeter to 50 millimeter. Particle size may be spherical, uniform size, porous materials are also used as in gel. Surface area, 1 gram of stationary phase provides a surface area ranging from 100 to 860 square meter, which are averagely 400 square meter. Column, functional group column examples. The functional group present in the stationary phase depends on the type of chromatography separation. In normal phase mode, contains the silanol groups, hydroxyl groups. In reverse phase mode, contain the following groups: C18, octodicyl silane, ODS column, C8, octyl column, C4, butyl column, CN, nitrile column, NH2, amino column. For other modes of chromatography, resins, ion exchange column, gel columns, chiral columns, affinity columns, etc. There are many new columns are also available. Detectors, as I told, detectors used to depend upon the property of the compound to be separated. Different detectors are available. UV is the best one, which is fixed in all the HPLC. Still there are many detectors are also there. You should know that. These detectors are based on the light absorption, UV detectors, characters of the sample. Two types of detectors are available. One is fixed wavelength detector, which operates in 254 nanometer, where most of the compound absorb. Other, variable wavelength. Usually nowadays variable wavelength in computer, variable when it is attached, variable wavelength detectors, and UV spectrophotometer will be there. That is a very simple, which can be operate from 190 nanometer to 600 nanometer, up to lightly it is touching the visible range also. Fluorometric detectors are also available, but the problem is the compound should have a fluorescence capacity. The detectors are based on the fluorescent radiation emitted by some class of compounds. The excitation wavelength, that means the visible wavelength, the emission and the emission wavelength can be selected. Excitation wavelength and the emission wavelength, that is two wavelength is needed for a fluorescent. Absorption will be in UV light and emission will be in visible light. So the excitation wavelength and emission wavelength can be selected for each compound if it is a fluorescent. This detector can more specific and sensitivity. The disadvantage is some compounds are not fluorescent, or you can say all compounds are not fluorescent. Refractive index detector is a common detector. This is non-specific and universal detector. It is not much used for an analytical application because of low sensitivity and specificity. Conductivity detector can also be used. Based on the electrical conductivity, that response is recorded. The detector is used when the sample is conducting ions, like anion and cation, which is possible. Amperometric detector are also available. This is about oxidation reduction. This detector is based on the reduction or oxidation, electron donating of the compound when a potential is applied. The diffusion current recorded is proportional to the concentration of the compound have eluted. A good principle which is followed for amperometric detector. This is applicable for compounds having functional group which can be either oxidized or reduced. This is highly sensitive selector or detector. photodiode ray detector is also available. PDA detector. This is a recent one, little before, 20 years before, 25 years before. Recent one which is similar to UV detector, which operates from 190 to 600 nanometer. Radiation of all wavelength falls on the detector simultaneously. The resulting spectra of 3D or three-dimensional plot of response versus the time wavelength. The advantage of this wavelength need not to be selected, but the detector detects the response of all the compounds. Very interesting results can be seen. Recorder and integrator, nowadays we are just connected with computer. Previously records are used by printing and detector amplification if necessary. This recorder baseline, all the peaks obtained with respect to the time. Retention time for all the peaks can be found out of such recording, but the area individual peaks can be known. Integrators are improved version of recorders. Some data processing capabilities. They can record individual peaks and retention time, height, width and peak length, and number of peaks, peak area, percentage area, etc. can be easily integrated. Integrated provide more importance of peak and recorder. Nowadays computers will give you all the parameters. Printers can be also connected and you can get the data, obtain data can be easily get a reason. Now this is a video which Madam Silicagel, she is from Pune of D.Y. Patel Institute of Pharmaceutical Sciences, Pune. She is Dr. Silicagel Gandhi. She has given a very good video about actually how to assay the paracetamol. I am not going to show because it is more than 25 minutes. Just see that she is showing the solvent system, and you can see the solvent system she is taking, and then she is degassing by means of ultra wave, that is ultrasound instrument, not by means of mechanical. By ultrasound vibration can be taken place in the air, unwanted air can be removed, and as we have seen, it should be done by filtration. Membrane filters, you see that membrane filter, vacuum is connected so that it will be filtered. See, there is a membrane in between this. See, she is keeping the membrane, and this is the reservoir. Clip can be followed to filter, membrane filter. And then after filtration, you see, this is the filtration taking place. After filtration, this is a solvent have to be prepared, and all the dilutions, she is doing the paracetamol tablet assay in HPLC. So dilutions you know very well. When you come to 7th sem, you will be studying in analysis how you are going to prepare the dilution factors and to find out the concentration by UV spectrophotometer and analyzing assay for a tablet. So, but you can go for this application even for various other techniques also. Crushing 20 tablets and taking the quantity. According to that, she is showing the experiment. And then after the dilution making by the standard flask, making proper dilution, you have to go for switching on the small compact HPLC. You see that the compartments degassing, pump, and the solvent system have been kept in the top. Computer is selected, and there she is giving the input of what is the compound which you are going to analyze and what type of solvent you are going to use and what is the separation. This is done by isocratic method. Already she is planned what is the solvent system she has to be used, because she knows. And then this is the using the degassing, any removed and the pump is on. This is a solvent system which you are using. She is selected already in the computer. So there is 4 solvent system, but the back one, the 2 only she is using for this experiment. And then she is turning it on and start for the operation of purging. The purging line removes all the air or trapped and gives smooth running. Now if you are you have to see the pressure control, and then after you can see that whether my movement of the solvent system is proper or not. Is it normal? You have to give the instruction by the computer. And then now we are going to take the samples. Which sample you are going to do, paracetamol, everything you have to do. And now you are going for the injecting area. Coming to the injecting area, what is the amount? Take in the syringe 20 micro ml and keeping in the not in the injecting signal, there is a knob you can see. You are injecting to the injection loop. This is rheodyne type of method of injecting. The sample is injected in the rheodyne injector, but only it will be in the loop. Understand? Loop type. Already I explained. And now you have to turn it. She is turning the knob. See, turning the knob, and it is injected into the column. You can see the peak absorption very clearly about the, and then come to the calculation part. You will take the area of the peak and you can see the peak areas, and by means of calculating the dilution factors and finding out the average of your dilution factor and the label climb of the tablet, and then you can find out what is the percentage of the label climb which is specified, and she has found that it is 101% of paracetamol is present in each tablet. So it is up to the IP mark, so it passes the test, and you can just give the option for quality control to release this product. Madam have given very good explanation how to perform this assay. You can listen to this in YouTube, it is available. She has given very good. Thank you. And now we will go to our class continuation. This is just to know about how to perform an HPLC. The person have to see. This is in our lab, in our institution. Students are requested to go and see in the instrument room and just watch the instrument, whether the teacher have told the exact thing or not. It is necessary for the student to go and see about that. Understand? So, and now application of HPLC. Like an examination point of view, I am not giving more examples. The student have to write if it is a 10-mark question. So application HPLC is being more widely used in several fields. It is used in chemical and petrochemical industry, environmental application, forensic applications, biochemical separations, biotechnology, food analysis. In fact, there is no field where HPLC is not being used. It is a versatile and sensitive technique which can be used in several ways. Quantitative analysis, it is nothing but identification of the compound. This is done comparing the retention time and the sample as well as the standard. Under identity condition, the retention time of the standard and the sample are same. If there is deviation, then are not the same compound. Qualitative analysis in quantitative amount. Application of HPLC in pharmaceutical industry, drug development. HPLC is used to identify, quantify and characterize drugs and their metabolites. Quality control. HPLC is used to check the purity of the new drug candidates and monitor changes during scale up. Stability testing. HPLC is used to test the stability of pharmaceutical products. Bioavailability studies. HPLC is used to study the bioavailability of drugs. Impurity proofing or profiling. In the profile, HPLC is used to identify quantify the impurities in pharmaceutical products. Cleaning validation. HPLC is used to identify residual compounds on the production line. Regulatory compliance you can say. HPLC is used to ensure compliance with regular requirements. There are many. I have taken only for an examination point of view. Application of HPLC in pharmacognosy. Separation of constituents separates the components in herbal extracts. Identification and quantifying compounds. Identifies and measures the amount of compounds in herbal mixtures, herbal formulations. You can go for study. Establishing fingerprint profile, creates profile of chemical constituents of a plant, a medicinal plant, mixtures and crude extracts. Standardizing complex herbal drugs. Standardizing complex herbal drugs. This is an important issue by the WHO, which is specifically they are telling. Multi-drugs using formulas estimates the presence of active markers, chemical markers, biological markers. You may be knowing about the markers. These studies can be done using HPLC in pharmacognosy. Very important instrument. Students have to listen to this class and make use of it. Thank you. Thank you for listening.